So then the second exercise in the book, this one is a little more complicated, but it says that you've got two files on your desktop. You've got the genomic DNA.txt file that contains a section of genomic DNA, and then you've got another file called an exons.txt file that contains a list of start and stop positions for that exon. So if you, for those who are not from a biological background, it's basically as if you've got, let me see if I can share this other screen. Okay, so it's sort of like this. It's like if you imagine this is your DNA sequence, which is that genomic DNA.txt file, then you've got a second file they're saying that has exons stop and start coordinates. So exon is basically what is going to code for a protein within the gene. So all of your DNA doesn't code for proteins, but there are sections in there that does code for proteins, and they've actually done some work to show us exactly at which positions in this large section of our DNA, at which positions we will be able to find the protein. So that exon file is almost as if it's saying, okay, at position 0, 1, 2, 3, 4, 5, so column 5, row 1, until column 6, 7, 8, row 1, there's a gene for fish, for example. Okay, so those codons or those exon positions, the stop and start positions are basically like that. They tell you exactly where the proteins are. So what they want us to do is to write a program that will extract these sections of the exons from the huge just mess of genomic DNA, and then concatenate them together into a new file. Okay, so the exons usually code for proteins, and they want them all to be concatenated together into a new file. So all of them as one single line of an exon. So this one I did just the old-fashioned way, where you actually have to remember to close all of your files. So just to show you again that there are two ways that you might encounter this or see this when you are reading other people's Python code. So there's a genomic DNA.txt file on my desktop. I'm opening it and I'm storing it in this variable name. I'm doing the same with exons. And then I'm also opening up my combined exons file. I've named this myself. And this is what the file is named that is on the desktop. So I'm opening that, but this one needs to be opened differently, remember, because I'm going to open this for writing. These ones are by default being read, as we learned in the previous chapter, because you can either put an R there to say that it's being opened for reading. But remember, we said that it's by default, it is on opening for reading. So it's basically redundant to put that in, because it's going to just open it for reading anyway. So unless you specifically specify that you want to open it for writing or reading and writing or penning, for example, it's going to open that for reading only. So this is something that I usually do. I would sometimes just put a little note there for myself, just to show me what the format is of the file that I'm working with. Okay, so the first thing is we're going to open the genomic DNA file that over here for reading, or we're going to read that file. So the .read method we are applying now to this open file. Now remember, we're doing .read because we just want to read the whole sequence in as one complete string. We don't need to read it line by line. However, the exon file we want to read line by line. Now let's just go to my desktop again so that we can have a look at what that looks like. So the exon file looks like that. It's got line by line. It's got all of those, the stop position, a comma, and sorry, the start position of the exon, followed by a comma and the end position, and it has that 4 times. And then the genomic DNA.txt file is just one long string of data, and basically we need to use this file to go, for example, position 5 to 58. So it's going to go 0, 1, 2, 3, where am I? 0, 1, 2, 3, 4, 5 to position 58, for example. It's, sorry, copying the whole thing. But it's going to go find that position, for example, in that DNA file, in the genomic DNA file, and it's going to do that over and over again until it gets to the end of here and says, okay, there's nothing more that I need to find, okay? Let me go back to this file. So just ignore this for now, although that is important. So we also going to need to loop through the exon file, which we are going to do. The exon file over there, we're using a for loop to say for exons. Remember this, you can name anything you want, but this is intuitive for me, so I'm using exons. Or you could have used positions in exon file, or a strip, like I said. And then in order to get out the first position in that file, which was a 5, I think 58 or something like that, we're using the delimiter that we read about, and that's going to split that file. So basically this looks like this first. Just focus on this part. It's going to be exon.split on a comma. So then when we add the comma, it's going to split it into two separate, so over here, it's going to split this by comma, remember, with the delimiter, and it's going to do that, right? So we're splitting that, but then we're saying the first one, which is position 0, this one is a start codon, right? Then it goes to the next line it's going to read, and it's going to say, do the same here and take the second element, which is at position 1, and store that in end. Now I'm also then converting it. Remember, this looks like this, but then I need to convert that to an integer, because I need an integer in order to for the part where I'm going to extract the positions. So then I took this and I just applied the int method to that, so that I can convert that into an integer. Otherwise it won't work. And I did the same for the end position. Then I say, how do I get the exon out? Well, I would need to extract it from the genomic DNA.txt file, which I've opened here, and it's open for reading. The string is available to me now. So I'm going to take that and I'm going to slice out of that this start position that I've just extracted and stored in start. Remember, this is an integer, 5. So basically, that's a variable right now, but if you look at it in terms of what the computer sees, it sees the first time it goes around, it sees 5 to 58, right? It sees it like that, because we stored 5 in start and we stored 58 in end. Okay, so if you look at it like that, and maybe it doesn't look that confusing. And then, so this is the part now. Remember, the instructions were that they were supposed to be concatenated to each other. So we've got this exon that's now storing the first exon from position 5 to 58. And we're going to eventually need to concatenate them all together. So at the moment, we need a place to put that. And we can't add the second. If you go back here around, it's going to go to this position in the exon. So after it's completed here, it's going to go back up because it's not done, and it's going to try and get this position out. But remember, we can't add this exon to anything because nothing exists at the moment. But we want this to be the initial part of the exon. So in order to, because we can't add something to something that doesn't exist, we create something at the moment for placeholder. This is an empty string. So this combined exons, the first time it goes around, contains nothing because we've put nothing in there. So we're saying to nothing, add the exon, add the first exon that we've just gotten, which is genomic position 5 to 58. So it's going to say combined exons, which at the moment, now we can't just say exon, we're just going to have to, because like I said, we're using concatenating and it needs something to concatenate it to. So we're going to concatenate exon to nothing, which is fine at this stage because it's not going to give us an error. Then it's going to see it's not done yet, and it's going to go to this position and now store in here 7 and 133. And it's going to extract the second time around exactly that, what we just said. It's going to store 72 and 133. Now this is not empty. This contains the first exon at that position. It's going to be a nucleotide sequence, obviously, and it's going to attach this now to what is in here, which is the first exon. And so it goes on until it finishes, and then it exits this loop and it looks at, okay, what's the next line in this code? Remember this, for example, if you're reading the code from the top, it's going to read all of this till here, till it comes to the for loop. But once it gets to the for loop, it doesn't go straight down to here. It stays in this for loop and goes down the whole time, back up, down, and up until it's done with everything that it needs to do according to the for loop's instructions. And only when it's on the last exon in this file, because remember it's looping through the exon file, only when it gets to the last one, it says, okay, my work is done. What else is there? Then it starts to read this. So now we've opened this combined exons file for writing. So it's now going to go take this combined exon file. My instruction now is to write and write what we've stored as the concatenated exons, which is stored in this combined exon. And then we're closing our exon file and closing and we should close our input file as well. Okay, so that was that solution.